Maths educational video. Convergence of sequences. In this video, you'll learn a few concepts, including limit of a sequence, convergence or divergence of sequences. Let's quickly recall what a sequence is. As we all know, a sequence is a set of infinitely many numbers. These numbers are defined in a definite order, typically written in this form. You take a letter, say A, with a subscript n. N is a positive integer, running from 1 to infinity. So A1 will be the first term, A2 the second, and so on. An is known as the general term. We must have learned at least two special sequences. The first is the famous arithmetic sequence. The characteristic of this sequence is the difference between any two consecutive terms is always equal to a constant, known as the common difference of the sequence. And this is a famous formula, the n term for an arithmetic sequence with first term A and common difference D. Another sequence we know very well is the geometric sequence. This time, the ratio of two consecutive terms is equal to a constant R, known as the common ratio. And here's the general term. Limit of a sequence. That's the main concept we want to explore. Given a sequence an, what we want to know is when n becomes very large, we say n tends to infinity. We want to know if the sequence itself will approach a unique finite real value. Let's look at some examples. Example 1 is a very simple sequence. An is 1 over n, the reciprocal of positive integers. When n tends to infinity, meaning n becomes very large, it's obvious that 1 over n will tend to 0, because 1 over n will become very small. So this sequence does approach a finite real value, which is 0 in this case. So when this happens, we say that this sequence is convergent. So please learn this term. Convergent means it has a limit, which is a finite real value. We can even say that an converges to 0, since we know the value of the limit. Or in symbolic form, we can write this. LIM stands for limit. N goes to infinity is written below, followed by the sequence itself. So this equals 0 means an converges to 0. Let me show you an example of a sequence that does not converge to any finite real value. This is an obvious example. The sequence equal to square root of n. Now when n is very large, so is the square root of n. So because this sequence doesn't converge to a finite real value, we say that the sequence is divergent. So divergent is the opposite of convergent. We can be more precise since we know the sequence tends to infinity. So we can also say that this sequence diverges to infinity. So far we have two examples. One is a convergent sequence, and the second one is a divergent sequence that has a limit of infinity. In the third example, I will show you a divergent sequence that does not diverge to infinity. And this is a famous sequence, minus 1 to the power of n. If you were to list down the numbers, you will find that this is a sequence that toggles between minus 1 and 1. And this goes on forever. So obviously the sequence does not approach a unique limit, because we have a choice between minus 1 and 1. But we need to have one and only one limit. So therefore this sequence is not convergent as well. In subsequent videos, I will show you how to find limits of more complicated sequences.